Alright, so today's lesson we are going to talk about the implicit differentiation. And so first, let us see what are the notations again. If ever you have or you haven't remember those notations for finding the derivatives of a algebraic function. So we are using f prime of x. Also we are using du over dx. But for this time, commonly or mostly we are going to use the y prime or also the dy over dx to notate that we are looking for the derivatives of the algebraic function. And let's see, so that we can understand what is the implicit differentiation. In this equation, y is equals to 3x cubed minus 4x plus 17. Y is expressed explicitly as a function of x. So it is said to define explicitly as a function of x because the variable y appears alone on one side of the equation and does not appear at all at the other side. However, sometimes functions are defined by equations in which y is not alone on one side. Let's see. For example, we have y cubed is equals to y cubed plus xy is equals to 3x plus 1. As you can see, both on both of the side of this equation. On the right side, there is x variable, and on the left side, we have y and x variable. So this is what we called y is expressed implicitly as a function of x. So in this form, the function is expressed in terms both of y and x. And going back to the first here our first equation, y is equals to 3x cubed minus 4x plus 17. It was very easy for you to locate or to differentiate this kind of equation. And the differentiation or the derivative of that equation is 9x squared minus 4 through the use of the constant multiple rule. So we differentiate the equation by getting the derivative of each of the terms on this equation. And now, how about when we are going to get when we are going to differentiate this implicit function here? So let's see the first example, the illustrative example, for you to be able to understand how can we differentiate that kind of equation here. Okay, for our first example, we have the f of x is equals to x to the 5th power. So when we're going to get the derivative of this, so it will look like f prime of x is equals to d over dx. D over dx, we use this to show that we are looking or we are differentiating this kind of equation. So time d over dx x raised to the 5th power. And what rule that we are going to use here is the power rule. So here, by the use of the power rule, since the function is x to the 5th power, we'll just have to make this exponent 5 to be one of our base times the x. So we have 5x raised to this. Since that we have 5 as our exponent, we just subtract 1 from 5 and we have 4 as our exponent now. So we have 5x raised to the 4th power. And there is dx over dx here on the right side of this term to indicate that we already get the derivative of that term, or the derivative of x to the 5th power. And when we are looking for the derivative in terms of the same variable, we don't have to put dx over dx. So the final answer will be f prime of x is equals to 5 x raised to the 4th power. And this is what we call the derivative in terms of the same variable. So let's take a look at the second example. Say we have our given f of x is equals to y to the 5th power. So in order to get that, just like what we did here on the first example, we are going to use the power rule. So we have f prime of x is equals to d over dx y to the 5th power. D over dx indicates that we are looking for the derivative of that term. And then it will look like as, or the answer will be 5 y to the 4th power by the use of the power rule. And then there is dy over dx. Why dy over dx and not dx over dx? Because we have y, or we get the derivative of y in terms of x. That's why we have dy over dx here at the right side of the equation. And also it is the same as like this. F prime of x is equals to 5y to the 4th power y prime. dy over dx is the same as y prime. That's a notation for the derivative. And this is the derivative in terms of different variable. So I hope you understand how you're able to get the derivatives of with the same variable and also with a different variable. We are just applying as well the different rule in differentiation. But of course, let's see the steps here. In general, it is not necessary to solve an equation for y in terms of x in order to differentiate the functions defined implicitly by the equation. So to find the derivative of functions defined implicitly, we use implicit differentiation. So here are the steps in implicit differentiation. First is we differentiate both sides of the equation with respect to x. Second is we collect all the terms with dy over dx or y prime on one side of the equation. Usually I put, or we can put those dy over dx or y prime to the left side of the equation. And last is factor out dy over dx or the y prime and solve for it or perform for it. Let's see the first example here. Now we are going to differentiate y³ plus xy is equals to 3x plus 1. So using the chain rule, first of course we're going to get the derivative of each of those terms. So we need, step 1 is we need to differentiate both sides of the equation with respect to x. And it will look like this. On the first term, the derivative of y³ is 3y squared. And we put dy over dx to indicate that we differentiate this term in terms of x. Then plus, since we have xy here, we are going to use the power rule. Of course, first we get the derivative of x, which is we don't and then we have the exponent, which is 0 since we only have x. That's why here in our second term we only have y, so times the second term y, and then get the derivative, or multiply x to the derivative of y. Since we get the derivative of y, then we can indicate it as, or we can denote it as dy over dx. As you can see, when we are getting the derivatives of in terms of x, when it is in a variable or same variable, we are not putting the dx over dx, because when we get already the derivative. But of course, when we are getting the derivative of the different variable like y in terms of x, we put dy over dx to indicate that we differentiate y, or we get the derivative of y. And then equals to the derivative of 3x plus 1. Since 1 is a constant, so we don't have any, we're not going to put anything here because the derivative of a constant is 0. And then we get the derivative of 3x, then it will be here, 3. And next step that we're going to do is to we remove this dx over dx. And then here, this y, we will going to transpose it to the right side of the equation. Then it will become negative y. So 3 minus y. So we collect all the terms with dy over dx here at the right side. Of the left side of the equation. And then we factor this out. That's why we have dy over dx times the quantity 3y² plus x is equals to 3 minus y. Well, of course, for step 3, solve for it, perform. We are going to divide both sides of the equation by the quantity 3y² plus x. And then also this part of the equation, 3 minus y over 3y² plus x. So that we can get the dy over dx alone here at the left side. And our final answer will be dy over dx is equals to 3 minus y all over 3y² plus x. Take care. So let's see the second example here. So we need to differentiate x³ plus y³ is equals to 9. Well, of course, for the step 1, we are going to differentiate both sides of the equations with respect to x. So we get d over dx, or the derivative of x³ plus the derivative of y³ is equals to the derivative of 9. And as we can see, we have 3x², the derivative of x³, and we indicate dx over dx here. We put this kind of notation to indicate that we get the derivative already. And then for the second term, the derivative of y³ in terms of x is 3y² by the use of power rule as well here. And we indicate dy over dx since that we differentiate this term in terms of x. And we have y as our variable. And on the right side of the equation, we have the constant 9. And by the use of the constant rule, since we have here 9, then the derivative of 9 will be equal to 0. And here, we are going to just remove this dx over dx and here dx over dx here. It will look like as 3x² plus 3y² dy over dx is equals to 0. And for our step 2, collect all the terms with dy over dx at the left side. So we only have 3y² dy over dx. And this 3x², I transposed it to the right side. And since this is positive, then it will be negative 3x². And then we need to factor out. In order to get that, we divide both sides of the equation by the 3y². And it will look like dy over dx is equals to negative 3x² over 3y². And then just cancel this 3. Our final answer will be dy over dx is equals to negative x² over y². Okay, let's see for more example. For this time, we're going to use the y prime. Yeah, y prime. And we need to differentiate x³ plus xy plus 4y² is equals to 6. Alright, for the first step, we need to differentiate both sides of the equation with respect to x. So we need to get the derivative of the first term x³ and then the derivative of xy. And on this part, we are going to use the product rule. And we need to get the derivative of 4y squared, and as well on the right side we need to get the derivative of 6. Okay, so the derivative of x cubed is 3x squared, and since we're going to use the power rule here, we just multiply the derivative of x by y. That's why we have y, only y here. And then we multiply the variable x to the derivative of y. That's why we have xy prime. Then y prime indicates that we get the derivative of y in terms of x. Plus the derivative of 4y squared, just use the constant multiple rule. So we have 8y, and then there's y prime to indicate or that we differentiate this term in terms of x is equal, and then is equals to 0. Why? Because the derivative of y of 6 is 0. We use the constant rule here. Next step, of course, we collect all the terms with y prime on the left side of the equation. So we only have xy prime plus 8y y prime at the left side, and on the right side is equals to negative 3x squared here. Transpose this 3x squared to the right side. Since this is positive, it will become negative 3x squared, and also this y. Since this is positive, then it will become negative y. Next step is, of course, we need to factor out. So we have y prime times the quantity 8y plus x is equals to negative 3x squared minus y. And then solve for it. We need to divide both sides of the equation by 8y plus x here. So these two equations, both of the equation. And our final answer will be y prime is equals to negative 3x squared minus y all over 8y plus x. So that will be our final answer. And for your own practice, you can try to solve this so that you can be able to know if you understand already how to get the differentiation of those implicit function. So that will be all. Thank you so much.